13.8 billion years ago, an event occurred that changed the course of time and space forever, the Big Bang. It was the moment when our universe was born, filled with stars, galaxies, and eventually our planet. But what do we really know about those first moments? How did everything around us emerge from a tiny, incredibly dense state? Let's look deeper into this amazing story. What is the Big Bang? The Big Bang is not an explosion in the usual sense, but an expansion of space that began from a state of singularity, a point of infinite density and temperature. It was the moment when matter, energy, space, and time began to exist. The Big Bang event was the beginning of everything from the smallest particles to vast galaxies. The primary stages of the Big Bang. Planck epoch 0 to 10 to the power of minus 40 for seconds. This is the moment when the physical laws we know today were not yet in effect. Space and time were in a highly distorted state. Temperatures exceeded 10 K in energy, was so high that elementary particles could not exist. Inflation 10 to the power of minus 33 to 10 to the power of minus 32 seconds. The universe expanded at an incredible rate, increasing in size trillions of times in a fraction of a second. This expansion smoothed out inhomogeneities, making the formation of large structures possible. Early hot stage 10 to the power of minus 32 seconds to 380,000 years. The universe was filled with quarks, gluons, and other elementary particles. Gradually, the first protons and neutrons began to form, from which atoms later emerged. Recombination and the first radiation 380,000 years. The temperature dropped to 3000 K, allowing electrons to fuse with nuclei to form the first atoms, mainly hydrogen and helium. This moment marked the birth of the cosmic microwave background, the first light of the universe that we can observe today. How did stars and galaxies form? After the Big Bang, the universe gradually cooled down, allowing gravity to begin its work. The slightest irregularities in the distribution of matter became the places where, over time, the first stars and galaxies began to form. The birth of stars. The collapse of gas clouds. Under the influence of gravity, giant clouds of hydrogen and helium began to contract, forming stars. In the core of each star, thermonuclear reactions ignited, turning hydrogen into helium and releasing massive amounts of energy. Supernova. When the first massive stars ran out of fuel, they exploded as supernova, ejecting heavy elements such as carbon, oxygen, and iron into the surrounding space. These elements became the building blocks for the formation of planets and even life. The formation of galaxies. The merging of small structures. Small gravitational clusters of matter merged to form larger galaxies. Different types of galaxies. Elliptical, spiral like our Milky Way, and irregular galaxies began to form from these primary clusters. The birth of our solar system. About 4.6 billion years ago, the formation of the solar system began in one arm of the Milky Way. This was due to the collapse of a giant molecular cloud from which the sun and planets formed. Stages of solar system formation. Protoplanetary disk. The rotating disk of gas and dust around the newborn sun, was the site of planet formation. Planet formation. Inner rocky planets, such as Earth, formed from heavy elements. Outer gas giants, such as Jupiter and Saturn, formed from lighter gases. Earth and its uniqueness. Earth happened to be at an ideal distance from the Sun, in a habitable zone where water can exist in a liquid state, which was a key factor for the emergence of life. Interesting events and discoveries. Cosmic microwave background. In 1965, Arno Penzias and Robert Wilson accidentally discovered the cosmic background radiation, a faint noise left over from the first moments of the universe. This discovery confirmed the Big Bang theory. Gravitational waves. In 2015, scientists first recorded gravitational waves caused by the merger of two black holes. This discovery confirmed the predictions of the theory of relativity and was a revolution in astrophysics. Studying distant galaxies. The Hubble Space Telescope has revealed galaxies that formed several 100 million years after the Big Bang. These observations help us understand how the structure of the universe originated. Baryonic acoustic oscillations. Traces of sound waves that propagated during the early stages of the universe have been recorded in the large-scale structure of galaxies. This gives scientists data about the density and distribution of matter. Why it's important. The Big Bang story is not only an account of the origin of stars and planets, but also a fundamental question about our place in the universe. That's why this topic is so important. Scientific understanding. Studying the early universe helps scientists test the fundamental laws of physics. Observing the cosmic microwave background and studying gravitational waves provide insight into the nature of time, space, and matter. Philosophical questions. Why does the universe exist? What is its meaning? Are we the result of chance or part of a grand design? Technological advances. The study of the origin of the universe has spurred the development of technologies such as space telescopes and particle detectors, which are finding applications in other fields as well. Current research. Scientists continue to unravel the mysteries of the Big Bang. Space telescopes. Observatories such as the James Webb Space Telescope study early galaxies to understand the process of their formation. Large Hadron Collider, CERN. Particle experiments help recreate conditions similar to those that existed just after the Big Bang. Gravitational waves. Their detection confirms the predictions of the theory of relativity and helps explore moments inaccessible to light observations. The mysteries of the Big Bang continue to fascinate the minds of scientists and ordinary people. It is not only a story about the past, but also a key to understanding the future of the universe. Knowing how stars, galaxies, and our planet came to be allows us to feel connected to something majestic and incredible. By exploring the story of the Big Bang, we not only come closer to understanding our origins, but also open new horizons for future discoveries. After all, every glimpse of the starry sky is a reminder that we are part of an amazing and vast cosmos.